Now I would like to introduce our first speaker. As I said, he is Adrian Turchet, and he is Senior Vice President of Strategy for RF Controls. Adrian?
Good afternoon, everybody. First off, I'd like to thank everybody for joining today's call, and a special thank you to the team at RFID Journal for putting on the 2020 awards webinar. This was very encouraging to hear from Mark that there's over 190 participants on this call, which shows that an online platform is certainly well received. So I've added a photo of Graham Bloy to give a shout out to our team in St. Louis, who have delivered on advancing our fourth generation product over the last couple of years. Graham has over 40 years of radar and beam steering experience and has spent the majority of his career with various government organizations, mostly focused on utilizing similar technologies meant for space exploration, military applications, such as missile tracking and battlefield identification. RF Controls might not be known to everybody on this call. However, our company was the first to repurpose electronic steerable phased array technologies, or high gain antennas, for the benefits of tracking RFID for long distances with high location accuracy. A little background on myself. My role with RF Controls is to accelerate the adoption of our overhead passive real-time location system, which again utilizes standard RFID tags, and to build a network of channel partners which provide the various installation, integration, and software platforms required to scale our system. Next slide. Looking back at 2019, it was April of last year that RF Controls released its CS-490 smart antenna, and we were fortunate to take home Best New Product. As channel partners and industry innovators look to future-proof and automate supply chain, visibility is clearly something that's making room on future digital transformation budgets. In this photo taken in Chicago during RTLS, what we set up here was an automated POS, self-checkout, and real-time inventory solution to mimic a store of the future, using just one overhead all-in-one reader and best butt antenna, or as we call them, CS smart antennas, or our customers call them ceiling tiles. In just 60 minutes, we had set up a store of the future covering over 1,000 square feet. It's also exciting that this was our smallest antenna that we've ever built. The first prototype 10 years ago weighed over 500 pounds, but it's our fourth generation series, which provides the groundbreaking 10-pound modular design for the vision of what is now the 490. Another thing to mention about Chicago, while we're on this slide, is it's the home of our manufacturing facility where our partners assemble, test, and ship around the world. With all the changes in the market today, we still remain the #1 overhead solution ranked by max scan speed, read distance, and pinpoint accuracy for both 2D and 3D tag tracking. Oops. Sorry about that, my computer froze. After completing the task of making the antenna smaller, cost-effective, and easy to install, our focus continues to shifting towards channel partners who are ready to scale and also ready to test and deploy new software driven by beam steering techniques to improve performance and perfect use cases. We're thrilled to be nominated for Best New Product, and we truly believe that our CS-490 benefits players widely across the RFID industry, as it fundamentally increases the value per tag for end customers when you can turn a passive UHF RFID tag into something that can compete with a battery-powered BLE Wi-Fi-based RTLS system. On this next slide, what you can see are the two available products today. On the right, you've got the CS-490, which again is another breakthrough for our 4th generation suite, enabling a fully expandable and interchangeable overhead system for all ceiling heights. While operating at 50 feet in the ceiling is not entirely new, since our 2nd and 3rd generation products have been deployed inside Lockheed Martin's F-35 facility for years, it is, however, fundamentally different in that we've improved the hardware and software significantly. As you can see in this photo, the max ceiling heights are designed to take into account the max read distance and to ensure a wide area coverage for each antenna. The black lines are scan areas and scan points, which can be adjusted using the RF Controls operating system. In this image, both antennas are defined by a 6x6 pattern equaling 36 scan points, which the antenna must steer to. They are evenly spaced, and it is similar to a raster scan. However, the sequence of completed scan points are subject entirely to our software algorithms, which are tuned to best match performance for the use case. For the scan points, focusing on the scan points for a second, the integrator or end customer can adjust them for different use cases to cover a smaller or wider coverage area and to increase location accuracy or faster scan speeds. Fundamentally, scan points are the main drivers of speed and accuracy in the system and are defined by our continuously improving operating system. This is why engineers like to say, we keep the antennas dumb and the software smart. As you can see in this image, the antenna is wide open at a 90-degree scan area. However, if the user requires the antenna to be clamped, so to speak, they can focus on any number of scan points inside of a smaller footprint. In this example, the total coverage area is defined by a formula: ceiling height times ceiling height times 4, which gives us a wide open area. And in this example, the CS-490 is covering approximately 10,000 square feet from a 50-foot ceiling. Moving on to the next slide. As you can see, it's a simple starter kit. It includes one or more antennas, a standard Cisco PoE switch, an Intel NUC is enough to run several antennas, and once mounted, the customer is seeing tags in minutes. Then we work alongside our partners to design and integrate larger pilots or commercial deployments and calculate the true ROIs. RF Controls operating system is the core software that administers all networked antennas. Together, they identify, locate, and track, and hand off to one another seamlessly. Its primary purpose is for deployment, monitoring, and integrating RESTful APIs or WebSockets to downstream IoT platforms. There are also pre-deployment tools that assist in designing antenna scan coverages and installation patterns, as well as a tag data analyzer. Architecturally speaking, RFCOS physically resides on the same LAN and subnet as all antennas it controls. And as the number of antennas increase, additional servers can be added to reduce the load. As you can see, the data we send downstream can include any number of the following: antenna ID, tag ID, zone, XYZ coordinates, confidence intervals, and so on. Before we go any further, it's important we examine various types of phased arrays because there is nobody else on the market today using the exact VESPA approach Graham and the team at RF Controls and our co-founder Tom have repurposed. And today, we have the leading patent portfolio in this growing subset of RTLS. It's our commercially proven approach which offers increased scalability and performance using a single beam to both transmit and receive tag ID and location data. This is also why the system performance is still good under high-density tag environments. This said, we don't pretend to read 100% of 400 tightly packed tags inside a pallet in just seconds while moving through a docked door. But if you give our antenna a chance to see your manufacturing or warehouse process we can pick and pack with you and count and assign to bins, boxes, and pallets to streamline workflows. Using parent tags for RTLS is a clean way to get consistent data streams across logistics. This said, once we can also be inside of a retail store and we're comfortable at the item level and still maintain great location accuracy. Next slide. This slide I pulled from our partners at Avery Dennison. Jason Ivey, who was previously with Impinj, spoke to it in a webinar we did just last week. And he made the point that there is a human connectivity layer between the physical and digital worlds, which is creating an IoT gap. At the top, you have the supply chain. Now, if we can accurately track goods as they flow through the supply chain, then we can better manage the challenges. And by applying the Internet of Things to supply chains, we can accurately provide visibility. In recent years, logistics systems have built capabilities into their platforms to process, visualize, and automate data from IoT inputs. These systems include ERPs, WMS, MES, TMS, etc. And the same logistics systems have enabled IoT with big data processing, increased cloud processing, visualization towers, and even AI for advanced analytics and automation. Hence, the system, which is required to even embrace next-gen RFID, is still being laid. As long as we're relying on humans for barcode or handheld RFID scans, or manually keying inputs, or even pen and paper to track goods, we will continue to have human error, significant delay, and processing inefficiencies. Think about the additional costs in cycle counts, QC checks, and dwell times or empty forklift blades. Next slide. Very quickly, I want to zoom in on 2 tag providers and a few tags which we recommend for either logistics or apparel tracking. Keep in mind there are dozens of different providers, shapes and sizes, and this is more for anybody who is following along and less familiar with RFID. As you can see, there are no batteries. These tags cost less than 10 cents at volume. It's important to note that as tag chip manufacturers improve their products, such as Avery Dennison, Confidex, and NXP, our antennas also improve. Next slide. This sets the stage for a few examples of what you can do with a CS-490, which is similar to the already deployed examples we're going to show you using the CS-445B. As you can see, here are 3 software-focused innovators which have developed both inventory and asset tracking RTLS software and are turning RF controls into commercially deployable solutions. Graham, Bob, Joe, and Dan, thank you, and looking forward to continuing to work with you. Next slide. This single antenna demo, performed entirely by a well-trained and very experienced channel partnership with Codegate in the UK, is a perfect example of how they turned a proof of concept into a fully commercial smart manufacturing deployment. Using our CS-445B, Codegate installed at a 30-foot ceiling and tested successfully how the customer can identify, locate, and track tools inside a wide area using 100 boxes in a tight pattern and over 600 RFID tags. Just think, this could be a smart manufacturing facility or a smart warehouse or a smart cross-docking facility. It demonstrates a scalable and useful starter kit in the beginning of a journey. It's a perfect example of bridging the IoT gap using RFID. Next slide. Okay, we're going to get a little more technical. It's important to understand both wall-mounted ceiling-mounted, and horizontal and angled antennas. Although horizontal ceiling mounts are the most commonly installed method, with the CS-490, it's capable of delivering longer read range inside lower ceiling environments when mounted on an angle. And that's what the photo on the right explains. This gives room to lower infrastructure costs and can also provide a full perimeter approach to a facility or a phase one commercial deployment, so to speak, if it fits the use case and the objectives. Lastly, precise measurements are important, and measuring all antennas back to a global origin does assist with stitching the difference between the physical and the digital worlds. Next slide. So we have worked with RTV Engineering, among other channel partners, such as CGI Federal, to get ready for 3D warehousing. This pilot with RTV was picked up by an article written by Claire at RFID Journal. It was a successful pilot which demonstrates a bin-level put-back use case. We tested over 200 of the 15,000 bins in this facility, and we outperformed the RTLS location accuracy challenge provided by the customer in 3D at all 7 levels of the racking system. The pilot used a combination of angled and horizontal mounted ceiling antennas, and we flipped the scan area from horizontal, like the photos you've seen previously, to vertical to account for either side of the aisles. We placed 1 to 3 scan points per 4-foot cubic scan zone, and we did this up and down, side to side. It was a long aisle, and the antennas were mounted at 28 feet. Again, this is a perfect example of why our channel partners are excited to get our CS-490 smart antenna, as it increases the total addressable market for overhead RFID or passive RTLS, and it adds to the scalability of our 4th generation suite of antennas. Next slide. Let's talk about some of the challenges and opportunities. What was hardware and what was software? Well, the hardware didn't physically change for this project with RTV. Maybe having a CS-490 would have helped, particularly if the ceilings were higher. But it was really the opportunity to control and automate the tuning of the scan areas and scan points, which provided a performance breakthrough. In this smart warehouse design, we added adaptive power to the list of software features, meaning each antenna knows exactly how far each scan zone or bin location is, and it adjusts every scan point to appear to the appropriate power level, ranging from 10 to 20%. In this example, to reduce the reflection and tag jitters at all levels down the racking system. A truly unique approach, which we see more benefit for high ceiling installations. The next phase, again, is a set of software-defined rules aimed to improve not accuracy, but speed. By setting the scan area to focus and maintain a rested scan area around the lower levels, as to prepare the antenna for motion detection, the antenna is essentially waiting for a tag on a bin, forklift, or person to approach the aisle, triggering an upcoming event is about to occur. This gives the antenna the best chance to get ready and focus on high priority scan points up and down the sides of a high ceiling warehouse environment. All changes in the scan area and scan point algorithms are, by design, meant to always provide the best balance between antenna speed, distance, and accuracy. Next slide. First off, I should preference this slide and new feature by saying our antennas have little to no issues tracking moving forklifts or maintaining full scan coverage area with enough speed, distance, or accuracy inside our commercial deployed facilities. And in all deployments thus far, we use a consistent wide area scan method regardless of ceiling heights. However, since the point is to discuss where is the C90 going and what are some of the new software features, our team has really taken motion detection to the next level by proving out further software features. We're calling it target acquisition tracking, and it's designed with higher ceilings in mind and larger scan areas. By adjusting scan points using predictive steering algorithms and informing the antenna of priority inventory tags, or even better, a cluster of tags assigned to a single forklift, for example, we can guide the steerable beam to lock on a target and follow its path while scanning a small area around it. Of course, you also have to keep an eye out for approaching bogies, which is typically addressed by adjacent antennas getting ready to hand off a moving target. This is something our customers call cool shit, and they like to point out, we can't wait for the new version of your software.
Adrian, you got about 5 minutes left.
Next slide. But when it's all said and done, it's again our channel partners which bring home and deliver the full solution, which enable customers to benefit from the immediate ROIs and true vision across their supply chain. Because a 4K TV with a poor cable provider is not a 4K TV. It's clear the customers who have installed our systems wall to wall are working on transforming the way they do business. From optimizing space, inventory, assets, and people, and eliminating errors and automating inventory counting. Forget about the ROIs inside the facility. If you can eliminate an entire plane and gain market share or better prepare for omni-channel retail, what does the ROI look like? Well, we encourage these discussions with our channel partners who are on the front lines. Next slide. Very quickly, this is just to show how Carboncast is turning forklifts into Uber vehicles, and the pallet in this analogy is the rider. In fact, if you can type in carboncast.io/Steerable, you can see the videos on their websites. We also encourage interested parties to visit Carboncast Innovation Center, which represents an RF controls deployment. Last slide. I pulled this from a ProLogis quarterly earnings, the world's largest warehouse real estate company. It's a good one because it speaks to why long range matters and why overhead RFID is an ideal solution to match the growth in e-commerce. As you can see here, the growth rate in rentable areas by ceiling height over 36 feet has increased significantly. And a stat I'll have to rely on the team from ProLogis, who must have done their homework. It says on the far right, for every $1 billion of goods sold online, it takes 3 times more indoor square footage to move the goods across a supply chain. So this has been a fire hose of data. And so we encourage people on this call to reach out to myself and the team at RF Controls. Let us direct you to an appropriate channel partner to assist with conversations. I just want to say thank you for listening, and we hope you vote RF Controls at the ballot box. I'll pass it over to you, Mark, for questions. Thank you very much.
Okay, Adrian, thanks so much. Folks, if you have a question, type it into the question tool, and we'll try to get to as many as we can here. What is the RTLS location accuracy, and how do you handle multipath due to reflections?
You know, the accuracy, does depend, but we like to say sub-meter accuracy. Again, you've got to determine how much accuracy you need for the use case and how you're going to adjust the antenna settings for speed and accuracy. So this can depend on the number of antennas or scan points per antenna. But in the example that we had up on the screen with CodeGate, they were seeing 1 to 2 foot location accuracy of those 6 tags per box. And what we have is a tool that allows you to look at the standard deviation between what the antenna says where the tag is and where it actually is in free space. And we encourage people to look at that data stream over a period of a second or a minute and compare how accurate we are for yourselves.
Okay.
With regards to multipath ambiguity, other than the fact that that's not one of the things that our customers complain about, we like to say we eliminated it. But we're processing the tag data at the antenna control module or the RFC OS level, and ultimately it's deciding what is the true location of that tag based on all the antennas in the array or the network.
Okay. Can this system work for multiple metal containers stacked on each other 4 to 5 feet high with side-mounted passive tags?
So it's a good question. I kind of forget where they were mounted on those bins, but ultimately they were mounted in the best possible location. A great example is, if you came to our booth at RFID Journal last year, we had an antenna directly below, or we had clothing directly below the antenna. And I remember a couple guys from, Johnson Controls coming over saying, how can you possibly see a tag looking, vertical? Our antenna does do some unique things. I'll give some credit to the tag and some credit to the antenna. Ultimately, if you're looking for to be able to see a tag on multiple different angles, dipole tags are going to be better in some of those cases.
Okay. It looks like RF Controls has upgraded not just its hardware, but also its software. Can you talk about RF Controls' vision for software going forward?
Absolutely. So I think we spoke to some of that with the target acquisition tracking. We certainly we want to make our software as easy to install for our channel partners, and so something as simple as Dockerizing the installation and the way we work on other people's networks is a great example of some of the things that we've changed over the last year. Ultimately, when you think about some of this tuning and scan points, there's ultimately more we could do to make that easier and automate it for the use case. So ultimately, we're trying to eliminate our own jobs in a deployment process.
Okay. Have you done any analysis of the cost of passive RTLS versus active RTLS? I've been with RF Controls for a year, and I think that's an area we need to get more involved in. It's something that our channel partners for sure have mastered, and I do resort to them. Bob at RTV Engineering, for example, he comes from the world of savvy technologies and has worked a lot with other RTLS solutions. In the case that where we were in that warehouse, active RTLS didn't hit the specs and didn't scale the way he wanted it, so it was a performance issue. But we also have customers, choosing to make the decision between us and active. And the difference comes down to some of the additional ROIs that can be driven by installing a passive solution, which you ultimately won't get to with an active because you're not going to tag everything in your supply chain. So I think the logistics cross-docking example is a perfect one. These are your customer pallets. It's easy to put an RFID tag, but you're not going to put an active tag on 10 million pallets going through your supply chain every year. So ultimately, you can maybe track a forklift with active, but you can't track your pallets. And I think the big IoT gap here is the pallet, not the forklift, and we can do both. Right. Okay. Adrian, thanks very much. That's all the questions we have.